this is going to lay an interesting foundation here that you can explore throughout the conference and think about on many different like planes of existence. It's not, people will see this as competition who are looking at it as outsiders, but I kind of want to open the path to collaboration here from all fronts. So everything in regards to Substrate, Polkadot, Ethereum, everything works together really well. So don't believe the clickbait media that talks about Ethereum killers, replacements, and so on. So this is not it. I want to show you the path to peace and freedom and love and happiness for everybody involved. So a little bit about me. I'm Bruno. I'm a technical educator at Web3 Foundation. My job is to copy paste. So basically I copy knowledge from some clever people's heads and paste it into other people's heads. My mission is to build proofs of concept, test new products, write tutorials, and generally onboard developers into our ecosystem. And I really like showing people what's possible, not for the sake of selling a technology or trying to push something on them, but more like to open people's horizons. And that's why I also like to switch up my my focus from time to time to try something I'm completely unfamiliar with. If you ever need to reach out and get in touch about anything at all, and like even besides this presentation, like anything else that you might be interested in, feel free to get in touch via Twitter, Telegram, LinkedIn, or email. I'm always available, and I will happily give you advice or just discuss with you your problem, idea, or whatever you might have in your mind to build in the Web3 ecosystem, either on the Polkadot or Ethereum side. I should mention that I will be keeping an eye on the chat on the side. So if you post any questions, I will do my best to address them as I go along, because I like to answer questions as they're posted. Otherwise, people will stay focused on their unanswered question until the end. That's not good. That said, what about my dog? Well, my dog is enjoying her beauty sleep, so no worries there. She can't really join me here right now. So let's get going. Now, many of you may have heard of Substrate, and before we dive into Substrate-based Ethereum, we should probably clarify what Substrate really is. So Substrate is an open source, modular, extensible framework for developing custom application-specific blockchains. And that sounds like a lot of buzzwords that are designed to kind of confuse and impress, and they are, because Substrate is essentially just a framework. So what Substrate does is it lets you get a foundation going on which you can build your own custom blockchain. And that blockchain can be as custom as you want to make it. But Substrate just removes a lot of the churn from your job by being extremely battle tested and used in production on many blockchains and in development on over 100 new ones. So as you might know, Substrate came out of Parity, who have built blockchains before for enterprise and whatnot, and they realized that they were reinventing the wheel all the time. So they figured, why not abstract these wheels and just focus on the meat of things on future projects. And Substrate was kind of born from that. So Substrate provides you with a database, which can be either ParityDB or RocksDB. And ParityDB is a new database optimized for fewer chaotic reads and writes, so for better performance, but it takes up more space on your hard drive. And you also have the standard RocksDB as an option as well. It also comes with networking out of the box, which lets the nodes connect to each other and the blockchain actually function, so the nodes can talk to each other. And it also has the transaction queue so that you have your typical mempool, right? It comes with its own consensus layer and block production mechanisms. Those are Aura, Babe. Those are Aura as the proof of authority mechanism for production of blocks, Babe and Grandpa for for finalization and block production, and InstaSeal like in Ganache. When you fire it up and you submit a transaction, it's instantly mined. There's no waiting for the block. So there are several these consensus and block production layers, but you can also plug in your own. We have a tutorial that lets you build a full clone of Bitcoin in under an hour on Substrate, and it contains many of Bitcoin's functionalities, actually all of the Bitcoin functionality, with significant performance improvements and virtually no downsides. So that's what Substrate provides at its core, right? If you're building a new blockchain from scratch, you spend a lot of time going through this stuff. You kind of you have to do some research and development for quite some time before you get to the stage where you're confident that this is battle tested enough for you to build your logic on. And a lot of teams lose a lot of time and frequently lose out to competition by being stuck on this step for too long. So this is now being used in production on Kusama and Polkadot, which are two blockchains that we started, and also on about 100 other blockchains that are all using Substrate to build their own application-specific logic, with or without the intention to connect to Polkadot later on. So some of those are standalone, some of those are not. Substrate is a non-opinionated, opinionated framework. So it tells you how to build a blockchain. It uses macros to do that, to make it easy and to make it safe. But it doesn't care if ultimately you connect to Polkadot and if you join the ecosystem. So Substrate by default gives you a standalone blockchain with its own consensus mechanism that you choose, that you pick, and whatever you do with it is up to you. So a lot of those chains are standalone right now. They have their own economies, while a bunch of others are planning to become parachains, the connected chains to Polkadot, and they will share Polkadot's security, so Polkadot's validators. Substrate doesn't care. Additionally, you don't just get this foundation, but you also get frame palettes. And frame palettes are so frame is a system for building plugins, modules for Substrate, is a way of building these modules. And these modules are called palettes. So Rust as a language has crates as plugins, as dependencies for your projects. And these crates are called palettes in the Substrate ecosystem. And this is because they're built in this special frame way that guarantees that they can be compiled into WebAssembly along with native binaries. These palettes are what you might essentially envision as Lego blocks. So you have one Lego board that is Substrate, and then you just plug in different blocks on top of it that form your house, fire station, or whatever you want to build. So these are standalone, highly atomic, very specific plugins for Substrate that you will pull into your project on demand and use to add features to your blockchain. And these features can be a bunch of things. You can easily develop your own custom palettes, but we have a ton of them out of the box, and a lot of third-party developers have also built their own palettes already, and there's also a bunch of tutorials on how to build your own. This is just an example. So the Substrate, a Substrate compilation process basically takes the palettes that you built into your blockchain, and this is, for example, this is a partial list of the palettes that are on offer right now officially, like in the official repo. So these are just some of them, the ones at the top. And the ones that are, colored in, they're the ones that we selected for our runtime. So we picked from some of these and we put them into our runtime. And the runtime is the state transition function that takes you from block A to block B. So when you need to move from one block to another block, there needs to be a function that tells the blockchain how to do that, right? It takes some input, it processes it with the function, and then the state changes, and so you get a new state in block B. So that's the runtime. And the runtime here is composed of Substrate's core and then all of these palettes that you put on top. So when you compile Substrate, you grab these palettes that you put in and you put them into the runtime. And in this case, for example, there's a bunch of them that do very specific things. So like the multisig palette will let you do on-chain multisigs, like native level multisigs that are composed of different addresses of different participants. The democracy palette will let you have on-chain governance, on-chain voting. There will Yeah, there's 2 elections in the list. Sorry. The treasury palette will let you have an on-chain treasury, like an account from which you can fund ecosystem projects and so on using on-chain governance or democracy. The pseudo palette will give you administrator functionality for your chain so that you have a single super key that can execute some changes in parameters, values, change the code, and so on. And so all of these things get combined, and then they have very interesting like interactions with each other. They can also affect one another, and you can compose a very complex runtime out of these individual palettes, and you get a very interesting, very dynamic blockchain out of all this that can be tailored to your specific needs. And there are other parameters that you can tweak, like block time. It defaults to 6 seconds, but you can also now tweak the maximum block size and also the block time production, like the time it takes to make a block. So you can decrease that and increase the size, and really really test your system to its limits and see what you can pull off. And then there's also a plugin called Cumulus, which if you put it in, will let you connect to Polkadot, but that's not important in this part. The important part is that once you compile a blockchain composed like this, you end up with 2 things. You end up with a binary, like a node that you run, and that when you run that, you have your blockchain, right? You can distribute that to whoever you want. Everybody who runs it gets their blockchain connected together, and you have a blockchain. It's already, Substrate by itself comes with a node template, which once you run it, you already have a blockchain. You don't need to do a single thing. It's a basic blockchain with basic cryptocurrency functionality, and it works out of the box. And then you can just add in palettes that you need. You can customize it, and then you can rebuild it, recompile, send it out to people who are running your nodes. Boom, your blockchain is custom, and you can use it out of the box. It just works. But the second part that you get is a WebAssembly blob, and this WebAssembly blob contains the runtime logic itself. So you have 2 parts. You have the node, or what we call the host, and the host has all of these RPC endpoints and the logic of the client itself. But then inside the host, you have this runtime. And when you compile it, there's this native runtime, and there's also the WebAssembly runtime. But the WebAssembly runtime, the WebAssembly blob, is saved also on-chain. So it's saved as a blob on-chain. It has like a 300 kilobytes of data at its infancy. So it's quite a chunk of data to save, but it's saved on-chain. And this is a big deal because when all of your nodes of your chain are running together, when they connect, they are constantly checking that wasm blob on-chain. And if it happens that that wasm blob has a specifications, has a version that's newer than the runtime they have locally running natively in their client, then they will download that wasm from the chain and run that instead. And what this lets you do is, if you replace the wasm code on chain with a newer version, then all the nodes of your chain will automatically upgrade. And this lets you have forkless upgrades. So you can upgrade your chain without forking. And this lets you very quickly have development iteration on your chain when you're building it on Substrate. Because if you have the pseudo palette installed, you can use that account to just switch out the code and upgrade your chain without having to request from everybody to, hey guys, why don't you just download a new binary now, log into your servers, replace your binary, rerun the client, let's hard fork this, change in there, and so on. And this saves a lot of trouble and a lot of headaches, because when you have to do feature upgrades on traditional chains like Ethereum and Bitcoin right now, you have to coordinate all of these anonymous people who are running your nodes to actually do the upgrade, right? And if they don't want to do it, they can hard fork, that's fine. But you have to coordinate it, and that's a nightmare on its own. And so because this is a nightmare, these hard forks usually encompass a lot of updates at once. So all of these minor updates will have to wait for a period until there's enough of them to have a named hard fork that will happen on a specific date. It's going to be a big event and so on. And so what you get is you push a ton of little upgrades into one huge update that everybody has to manually execute, which is troublesome and bug prone and error prone, and kind of an outdated way of doing it if you think about it. So this way, you with the help of the democracy palette. So with this combination, you have on-chain governance where all the token holders of a chain can vote on whether or not they want to include a certain code upgrade on-chain. And if they do, that code upgrade is going to automatically be enacted. Nobody has to trigger any button. Nobody has to replace a node. Nothing has to happen. So if I upload a proposal with that code and people vote on it through the democracy palette, then that proposal will simply take effect when a certain block is reached, and the runtime will change itself. What you get is this forkless upgrade, so that your chain just automatically upgrades. If you're running a node on a Raspberry Pi in a closet somewhere, you don't have to touch it for months. It's just going to keep updating through new runtimes that just appear on chain. If there's something super truly controversial or the chain breaks in some unpredictable way, of course you still have the option to hard fork the standard way. But this makes minor upgrading and iterative development incredibly easy and very powerful. And it lets you really develop your chain like it was meant to be developed, like piece by piece, so you don't shove everything in at once. So why am I telling you this? Well, just to demonstrate that Substrate is a powerful platform and is an excellent platform for developers to kind of, to break into the blockchain space. If somebody wants to build their own blockchain, Substrate is an excellent, amazing platform with a huge developer ecosystem. And because of its versatility, it can support literally anything, as you'll see. So right now, excuse me, right now on Substrate, we are running two blockchains in production, which are notably Polkadot and Kusama. Kusama is the canary network for Polkadot, or at least it started out that way, where new palettes that would be developed would first be deployed to Kusama, but Kusama has economic value. The tokens have economic value because we wanted to incentivize people to break it. If you can't gain anything by breaking it, then people are not going to bother by breaking it. And so Kusama has kind of evolved into its own awesome little chain that, not even little, active chain that's super hacker friendly, kind of edgy with weird use cases, friendly to experimentation, and not too risk averse. And Kusama has a lot of users and a lot of fans. And Polkadot is the more conservative, slower to move, more serious cousin, right? So that's the in-production enterprise super blockchain, if you want to call it that way, while Kusama is the more flexible one. They're both in production. They both have significant economic value behind them already. And they've all had dozens, if not hundreds, of runtime upgrades applied already through the forkless upgrade method I described earlier. And it's really been working well. These are actual examples that on-chain governance not only works, but can work for upgrading the chain's logic itself. And that's super cool. So, but there's kind of a problem in that the Substrate developer ecosystem is very young. And when you compare it to Ethereum, which many people want to say that Polkadot is trying to kill or replace Ethereum, that's not true. So Polkadot is, the tide that floats all boats. Polkadot will enable all chains to connect to each other. So every chain that connects to Polkadot will add its features to all the chains that are already connected. So by connecting Ethereum to Polkadot, the other chains that are already there will simply get access to the awesome DeFi ecosystem, Solidity ecosystem, and developer ecosystem of Ethereum. That's it. And Ethereum will, on the other hand, get access to all of their stuff, like, I don't know, anonymous transactions on Monero and Zcash or whatever. So this is just cooperation. There's no replacing here. And Polkadot and Kusama, they don't actually have smart contracts. So these are relay chains. They are intended to facilitate communication between chains. Kusama will have its own connected chains. Polkadot will have its own connected chains. These two networks have diverged, and they're targeting different audiences. But they don't have smart contracts built in. And this is because these connecting chains, they have to stay as light as possible. They cannot have this logic in them that would bloat the state and create problems for, when we get a lot of chains. You can't really serve smart contracts as well from the same state. The idea is that a connected chain would have smart contracts, and then you would talk to that chain through Polkadot or Kusama, and these smart contract chains could talk to each other. And so we have also a palette. It's not on this list, but it's called contracts, and the contract palette is our DSL. So that's the language for developing smart contracts. It's based on Rust. It's Rust-like. Again, bunch of macros. And Ink is used to build these smart contracts as WebAssembly again. So it will include them in the runtime that's compatible with the chain. And it's releasing, I think we are on release candidate 2 or 3 right now. So version 3.0 is coming out very soon. The thing is that Ink is so young that it is amazingly powerful. It is crazy powerful because it's based on Rust. It's very versatile. It's been developed with some best practices in mind from the get-go. But it's also very young. So it's like, Baby Yoda. It's very young, very powerful, but not aware of its power yet. Nobody really pushed its limits, and it didn't mature yet because there's no developer community behind it to really, push it to its limits. On the other hand, you have Ethereum with its awesome Solidity ecosystem, many devs, many tools, like Truffle and Ganache alone make up for a huge part of that, and are, I think, some of the tools that most of us broke our legs on in the beginning. So there's very few Solidity devs that haven't had significant experience with Ganache, Truffle, and their stuff. So that's kind of a gap there, right? We are missing the developers that we want to really kind of foster the smart contract ecosystem on the Polkadot side of the Web3 ocean. We will get there, but it's not there yet, and we'd really like some more hands on board. And then you have also all this tooling that I mentioned. So you have these RPCs that are standardized in Ethereum with a bunch of tools, many UIs. You have these hard hats and whatnot. The code checkers, the static code checkers, everything's there to make development with IDE plugins and so on, to make development with Ethereum as painless as possible. Now, with Substrate, you also get a bunch of RPC calls in the mix. It's very standardized, and Substrate has this added advantage that every Substrate chain will automatically expose metadata about that chain. And this metadata will be exposed through the RPC interface of the node, of the client. And it will contain literally everything about your chain in terms of function, method, error, and event descriptions. So this metadata will tell you everything about your chain, including code documentation from the source code itself. Actually, let me demonstrate that real fast. So every chain, this is what I'm doing now. This metadata will tell you everything about your chain. Let me zoom in here. Will tell you everything about your chain, and it will have all of the modules, all of the palettes, all of their functions, all of their arguments, all of the events, and all of the errors, including the documentation about your chain. And what is this good for? Well, this bunch of data can be used by user interfaces such as this one to self-modify. So this one user interface can be used to connect to a bunch of different Substrate-based chains. So these are in development, these are live. And the user interface will change automatically based on which chain you're connected to. And it will do this based on the metadata. And so if I connect to Polkadot, you will see here on the network, I have 3 options: Explorer, Staking, and Event Calendar. That's fine. But if I connect to Kusama and switch, the user interface will auto-modify. And if I look into network now, I have an additional option, Society. And Society is like an on-chain DAO that will let you join it if you tattoo yourself with a logo of the chain and the index of the last member. So it's like a human blockchain project that definitely wouldn't have a home on Polkadot because it's too edgy. But over here, we already have 28 members. And for more bidding. So this DAO rewards you with the pot, with the money in the pot, if you get a tattoo and others vouch for your proof of ink that it's legit. So you can see here that this metadata had a direct effect on what's shown in the menu. And these UIs, they can rely on this metadata to show you this different stuff. And so this is pretty cool, right? You have this metadata that lets you use one wallet, like one mobile wallet, to interact with all the Substrate chains that are out there. That's great. And we have a bunch of tooling under development. So that's really the ecosystem is developing. But but a lot of people are, again, dependent on the stuff that exists in Ethereum. And we just don't have that. And we'd like to have that stuff. And stuff is being developed that matches some of the Ethereum stuff, feature by feature, and that's great. We're all excited about it. But again, we would like to bridge gaps, not build moats. And so we'd really like to get some developer mindshare from Ethereum over, not as a exclusive transition, but like, hey, check out what we have. And right now it looks like this. There's a bunch of people in Ethereum. There's a few people in Substrate and Rust and so on. Definitely fewer people. And we think it doesn't have to be this unbalanced. It can be as many people on the left as on the right. And so we'd like some ETH developers to just check out the stuff that exists there, see what's interesting, maybe give some ideas, give some feedback, take something that's good back to Ethereum and get something that's awesome from Ethereum over to us. In our case, we'd like to hang out, but the developer mindshare wasn't really that interested because it really is a huge gap. If you don't have Rust experience, Rust is not exactly the most friendly language to learn, and it doesn't help that you get exposed to it through Substrate, which is kind of like learning JavaScript through jQuery. And not that it's impossible, but it's not exactly catering to best practices if you approach it that way. You'll get somewhere, but it's not going to be it's not going to be as native as you maybe want it to be. Justin, I'm talking about real actual tattoos. So people get actual tattoos of the chain logo to get into the DAO, and then they are rewarded from the pot. I can talk about that later if you're interested. And actually show you what's going on. I know it's Kusama, right? It's like if you wanted the blockchain that's built for the people who live in cyberpunk, like the games universe, that's Kusama. And Kusama is open to this really weird stuff. So yeah, there's almost 30 people who got Kusama tattoos right now, and they've been very creative with them. Like they can be like creative barcodes that you scan and then the index shows up or stuff like that. It's very cypherpunky and cyberpunky. So developers weren't too keen on moving over because it's a huge knowledge gap, right? I'm really trying. I'm doing my best on to move the web development part of Ethereum over in gentle steps with some tutorials on .leap.com. So there are tutorials for easy user interface building for Substrate chains, and that's gotten good feedback because it's not as jarring as a jump into a new ecosystem as it might be with going into Substrate. But there are other ways to merge the ecosystems and make everybody hang out and go to a barbecue or something together. And that's our, let's say, clone of Ethereum on Substrate. And this was done by PureStake, a company that is actually a sponsor at this conference. And Alberto from PureStake will tell you more about some of their work in a later talk. Right now, I'll talk about the actual implementation that was done at the core level that enabled this, that actually made it possible. So on the smart contract level, we have the EVM and Ethereum, right? And many devs, many tools for that. So to match that, we created Palette EVM, which is a palette for Substrate, which as you plug it into Substrate, you get EVM in Substrate. So the Ethereum virtual machine is built into Substrate. That's it. You just put it in there and it works. That said, just the EVM is not very useful, right? Because Ethereum itself, all of the nodes have these RPC endpoints that the various tools have to call. The wallets need something to connect to, and RPC endpoints are not the same between Substrate nodes and Ethereum nodes, not to mention the ports, not to mention the encoding and so on. So to get around that, we also have Frontier. And Frontier is like a collection of pallets that make all of this possible for a Substrate chain. If you include Frontier into a Substrate chain, you get the EVM, you get Ethereum-like block production that can be translated, that can be understood by the EVM, and you get all of the matching RPC endpoints that exist in Geth and similar tools. So, what does that actually mean, right? Well, it means that everything that exists in Ethereum can now work with Substrate-based Ethereum. So by including these pallets on Substrate and compiling them, not only do we get the replicated functionality of Ethereum today in full, we have Ethereum. So we have everything. We have RPC, we have EVM, we have block production, we have all the tools, we have all the wallets, everything is supported. And the Solidity code that you may have written for a previous, for Ethereum itself, just works, right? And so we are hoping that this will entice people to just at least come check it out, because you're still developing in the same environment, in the same ecosystem, but now you're in the Substrate ecosystem. And what that's going to make possible for you is to interact with all the connected chains on Polkadot, so you have a much richer environment to explore. But also you have some features that you don't really have on Ethereum. By doing this on Substrate, we in the Ethereum copy inherited the functionality of Substrate that I mentioned earlier. So we have on-chain democracy, which means you can use your ETH in this space to vote for on-chain changes. So actual on-chain democracy that's been proven to work. And you also have forkless upgrades. So you can upgrade this Ethereum without having to do these manual forks that take a long time and so on. So one example is the EIP 1559 that's been in development for a very long time, and that will have to be pushed in with who knows which hard fork and so on, and wait how many months. In this case, it could be a single runtime upgrade that just adds EIP 1559. Additionally, because this is out of the box a proof of stake blockchain, Substrate, then this Ethereum is also out of the box proof of stake. This Ethereum is not mined. It supports proof of stake out of the box. So you get a validator community and you can start running it as nominated proof of stake, which is the default that Polkadot runs at. So this is I think pretty cool. Naturally, there are some differences, and so this project is called Moonbeam by PureStake. Moonbeam is this Ethereum clone that will be going into production and will be connecting to Polkadot as a parachain, which means that you will by default have the ability to not only communicate with every chain in Polkadot, but also with Ethereum directly, because there are many bridges under construction already that will get Ethereum to talk to Polkadot. So now you have a way to directly communicate with Ethereum from the Polkadot ecosystem, and also with Substrate-based Ethereum that is already there, that will let you have native level communication in an Ethereum format. And we think that's actually very, very cool. I'm very excited as an ex-Ethereum developer. I'm very, very excited to get back into it, and I've been having a blast playing with it. But even so, you might be surprised. You might be wondering why we would build a clone of Ethereum, because we have Ethereum and it works and everything's there. The DeFi is there, the games are there, the products are there, the enterprise is there. Everybody's there. Everybody's using that. Why would we build a new Ethereum? Why would we do this? Well, because of that interoperability. This is a visualization of the Polkadot ecosystem. And this gray circle in the middle, that's the relay chain. The relay chain has these black holes. These are the parachain slots, the slots into which these other chains can connect. The purple lines are validators, which are randomly shuffled to validate one parachain at a time. The pink blocks are these parachains that connect to these slots. And so if a pink block has a gray block after it, that indicates that the pink block serves as a bridge, because you can't really connect existing blockchains into Polkadot without helping Polkadot understand what their block transition function looks like, right? So Bitcoin has one way of going from block A to block B, and Ethereum has another way of going from block A to block B. We have to translate that into a way that Polkadot understands, and so this bridge acts as a translator for that. So you have the gray box is the outside chain, existing chain. The pink one is the bridge parachain, and then it connects regularly. And the pink boxes without the gray one, those are native parachains that don't need translating. They use that Cumulus plugin to be automatically compatible. And so what do we get by? Oh yeah, and we also have these ideas about the nested relay chains. So one chain might be a child of another chain, which will have its own parachain and so on, but that's outside the scope of this. These pink lines in the middle indicate messaging between the chains. So messages, transactions sent between the chains. Looks complicated, but it really isn't, because it's just going in all directions. So our story looks something like this, right? You have Moonbeam as a level 1 parachain here, and it lives here, it breathes here, it exists here. It works with Polkadot and all the other chains that are connected in here. And then it can send, we have Ethereum here as a bridged chain. So we have it outside of the ecosystem, but it's bridged in through a bridge parachain. And so if you want to send a message from Ethereum to Moonbeam, no problem. So you want to transfer your state from Ethereum to Moonbeam, because Moonbeam is emptier, faster in block production, cheaper to deploy on, no problem. Copy the state of your dApp into Moonbeam, continue there. Use Moonbeam as your side chain, whatever. The option is there. What you get is, with this merger of ecosystem, you get access to all of these other coins. So now you can optimize. Your dApp can now become as application specific as you want it, because there will be many chains with many different purposes that you can now use to really drive home the point of your application. And because all of this is in the same ecosystem, and all of this is driven by the same metadata that is exposed automatically by the nodes built by Substrate, including these bridge parachains, you will be able to use a single user interface, a single wallet, to interact with all of them, including the bridged Ethereum. Because when you use a Polkadot-based, like a Substrate-based UI to interact with a bridge that is bridging an external chain, that bridge will know how to translate that command and forward it to Ethereum in your name. So you will be able to interact with Ethereum itself through a UI that understands all of these other chains. And so there's no more clumsy switching of extensions. There's no more clumsy switching of UIs and 1,000 mobile apps for 1,000 different chains. Of course, some chains will have bespoke user interfaces that are very specific. Like if a chain is dealing only with NFTs, then of course you're going to have their own NFT app just dealing with that to not confuse new users. But you will be able to issue cross-chain transactions to a singular UI, and you will have these true cross-chain composability of like insane, unseen levels of DeFi and other aspects that we've not been able to imagine yet when this stuff opens up. And this is why this is being built. So we want the developer mindshare, the developer ecosystem, to explore the option of being connected to all the other chains and also to the mothership, and to experiment with offloading its the overwhelming demand into Moonbeam and into Polkadot in general to help it scale, to help the ecosystem grow, and to again, rise the tide and rise all the boats with it. So this is our end goal here. And now, in the short time we have left, let's see it in action. I want to show you a brief little demo of how this would work. So what I did, you can actually get all of the instructions to do this on moonbeam.network if you're interested. I will share the link in chat if you want to check it out. So it's moonbeam.network. If you go to the docs, there's a bunch of tutorials there. My tutorial uses slightly modified code, so it's not going to match it line for line, but I'm using a different version of Solidity, and I've updated and I added a new contract, but minor stuff. So when you clone, it says here in the docs under getting started for the local node. So the biggest problem with Substrate-based projects when you're getting started is the fact that you need to install Rust and prepare your environment to compile Substrate projects. And compilation takes a long time. So on my rig, which is a desktop rig of significant power because I like gaming, it takes 10 minutes to compile a Substrate node. On your average laptop, it'll take 30 to 40 minutes. Like, I think the average is 30 minutes or so. So this is, luckily, you only have to do this once. You only have to do the 30 to 40 minute process once, and then you will have to do a 20-minute compilation one time per project that you're compiling, because every new Substrate installation will have to be compiled from scratch, which takes, again, depending on your computer strength, 5 to 20 minutes or so. That said, once you set this up, you're good to go. And so I did this here. My Moonbeam node is fine. And so you can, every chain that you power up that's based on Substrate has this dev option. And if you run it in dev mode, you actually run the chain as a self-sealing mechanism. So it produces its own blocks. And it also generates and unlocks some accounts for you that have a balance so that you can test sending out and so on. So if I run this, you can see here, now my UI looks a little ugly. This is because my terminal emulator doesn't support UTF-8 emojis, so there's a lot of question marks. In your terminal, it's going to look much prettier. Actually, this is what it looks like when you, I think I have here, oops, sorry about that. I think I have here, oh, where are you? So this is what it looks like when it supports it. So these are some pretty emojis. But yeah, that's Windows. Anyway, I'm now creating blocks, right? So my Moonbeam node, this is the Moonbeam, the copy of Ethereum. It's running on Substrate and it's creating its own blocks. It's in block 8 right now. And the UI that I showed you before, you can actually switch it to connect to your locally running node at any point. You just go to development, go to local node, switch, and it's just going to connect to your locally running node. You can see here we're on block 10. It's just reading the events that are happening. If I check out the accounts, you will see here that we have some accounts. Though over here, we don't have, like typically in a Substrate-based chain, when you clone Substrate node template, you will have Alice, Bob, and Charlie. Alice Stash, Bob, and Bob Stash will have a bunch of money in here. But because right now in Moonbeam, at this stage of development, the account balances of Substrate-based accounts and of EVM-based accounts are separate. They're working on merging those. They will not appear in this UI, only in the typical UIs that you use for Ethereum, typical Ethereum interaction. But all the typical stuff that you expect from a Substrate chain is available to you here. So you have accounts, address book, transfer, network, explorer, event calendar, developer. And you can have your sudo. So it comes with the admin module. If you run it with a dev flag, it comes with the admin module. And you can check the RPC calls, extrinsics. So extrinsics are like external commands to any Substrate chain. Like those are commands that you execute, and then the state will change based on those executions. So so extrinsics, you can just, Alice will submit a system remark, and the remark is like just graffitiing the block. So I will graffiti a block with this remark, but I can't do it right now because Alice doesn't have a balance, so never mind. In RPC calls, you can interact with the node directly, and you can see here, if I call the get metadata function, I get the metadata of this chain. And you can see the scroll bar on the right, how verbose this is. It literally comes with documentation. So doc blocks from the code, parameters, function names, everything that exists in your chain is output here and can be parsed by any UI that connects to it, any client that connects to it, and turned into a custom bespoke UI for your chain based on what it exposes, which is pretty cool. So we are connecting to it right now, but this is not very useful, right? Because these are not Ethereum tools. So let's connect MetaMask to it. I have here MetaMask, and I'm already connected to it. You can see here that my account 3, which is automatically imported, but you can also find it in your Truffle config. So if you clone this project, it will, if you go to the tools Truffle folder, you'll find a Truffle config file with the private key of the account that has the preloaded balance so that you can experiment with it. And so the chain is already running. The chain is already running, and this account has 123,000 meth. So Moonbeam ETH in the balance. Yeah, as Alberto says, the private key is also in the tutorial, so you don't have to grab it from this file. It's also there. You can just read the tutorials. So now let's try to send it to another account. I have another account, like here, account 4 is, I don't care, has 0 meth. So let's go to this account, send. Now let's send it to account 4, 5 meth, next. And now we are sending the transaction. You can see here that it was visible that it's doing this. The transaction was submitted, and we were just waiting for the. Ah, yeah, okay. So this is not going to work because I forgot to reset my account. So as you might know, when you are using the same network ID and the same RPC, but you didn't reset your account, the nonce of the account will stay higher than 0. And if your chain started from 0, then your transactions won't work because the nonce also has to be at 0 if the chain is fresh. So we can just reset account, go back, and then send from one to the other. 4, it's 5, boom. All right, here we go. So this should work now. There we go, confirm transaction. And we now have 5 meth in the account 4. That works, that's a simple transfer, right? Simple enough. MetaMask connected to it. If you look at the connection parameters, you can see here that we are actually using, so you can connect it like this. You use the endpoint is 127.0.0.1 port 9933 by default. This is also in the tutorials, and you use the chain ID 43. That's it. I put meth here. You can put anything here, and that's how you connect to it. So it's a simple RPC endpoint that you are familiar with from the ETH stuff that you did. Now, if we go to the folder that contains Truffle inside of the repo that you clone from the Moonbeam docs, you will find these files. You will find the Truffle config, you'll find the contracts, and so on. So let's check that out. In Truffle config, you can see here that we're targeting Solidity 0.73 and above, and the private key provider has already been set for you to match network ID 43. And for development, you will be targeting localhost, so your own local node. There is, I should mention, a testnet live and available to everybody. That's called Moonbase Alpha. So that's a live version of Moonbeam that you can use. It's kind of like just a live shared testnet. You will need to request some tokens for it from the team. But once you get them, you can use it as any other testnet. It's going to be periodically reset, so it's not a permanent testnet like a Rinkeby or Kovan, but it's on its way there. So that's the point of it. It's going to be there we go. Alberto shared the docs, so it's going to be a testnet that you will be able to use in perpetuity to test your stuff. But this is simple enough. Like running a local copy is extremely easy. It's a few commands that have been vetted to work on all platforms, and I recommend you play with this because locally it's way easier, right? As we'll see now. So if we check out the contracts folder in here, we'll see my token, and this is going to be a simple ERC20 from OpenZeppelin, just my token, whatever, we don't care. And also, I pulled in here a raffle that I wrote ages ago on Ethereum. So somebody can call the play function, submit a tiny bit of ether in there, and then we have a certain number of winners that can be drawn. and the winnings are sent out to a specific address. So this was a charity raffle that I did real quick for a conference years ago, and I updated it for 0.73. Everything else is practically copy paste, just modified to work with a recent version of Solidity. This was on 0.4 originally. And so in the migration for Truffle, hopefully you're familiar with this format, we are just importing the contracts and then just deploying them with their basic constructor parameters. So raffle doesn't take anything. My token takes the total supply. This is 8 million tokens. Sorry. And so now we can potentially run Truffle compile. So now, there we go. Okay, so I compiled this previously, so everything's still up to date. The contracts are compiled, and then we can just deploy it to the development network. So the development network, as we've seen, is our local server. So let's do that. Our local chain that's still running here in the background, but is no longer keeping up. There we go. So now it's replacing my token with a new version, and now it's replacing raffle with a new version. And there we go. So Truffle works out of the box with this. You do have a custom provider, excuse me, so that it knows which chain it's talking to. Other than that, it's all the same. Works out of the box with Truffle. And so let's see the token, contract address. There we go. There we have it. Let's add it to MetaMask. There we go. So that's going to be account. It's by default it's added to this account. So let's add it. We have assets, and let's add the token, custom token. That'll be this one. Next, and we have 8 million of these. All right. So let's send 8 million of these to my account 4. Let's send 100 of these with something like 55,000 gas limit. And this should work as soon as the block is made. There we go. So now my other account should have these tokens. There we go. Yeah. Oops. Okay. Assets, token, custom. Oh, go. 100 tokens. So custom tokens work. Cool. That's really great. What about this raffle? Well, it's a bit tedious to interact with it through directly through JS. So let's quickly try and build a UI for it. And one-click dApp, really great tool, awesome stuff. So let's create a raffle. Now, our compiler told us that the contract address of the raffle is this, which means we can put it here. And let's grab the ABI of this. Build raffle JSON ABI. Okay, so we'll grab the ABI of our raffle contract, plug it in here, and we'll also drop this to private localhost. I think I have some extra artifacts or something, maybe this and this. What? Let me grab the ABI from here because I don't know what it wants from me in this case. Aha, it works. It's fine. It worked before. I just missed the arrow. And so we'll create the new dApp. It's building the UI. Sorry, Alberto. Yeah, but the remix part is not important anyway. And so we have our UI for our raffle connected to my local network. You can see here the blocks are being produced and registered in the UI. It all works. It has no idea it's not connected to Ethereum. And we can also just play the game. I can put in the address of, I don't know, whatever I want to put in. So this address, let's put this, and I'll send in 0.05 ETH, sign and submit. Is this account poor? I should probably switch. Oh no, it's fine. It should be good. All right. That is because 50,000. I don't know why it's playing up. Hold on, let me switch to another account. This one. All right, that should do. Now we're playing as this participant. There we go. And if we check out the unique players, if we check out the first player, it's that address that we just pasted in. So it works just fine. The raffle is configured to only be able to draw a winner after 15 minutes or something. So we can't really do the draw right now. But basically, you add players in. Once there are enough players, I think 5 or so you need to add in. And then you just draw. You just call the draw function, and it's going to draw a winner. In the meanwhile, you can read all of the different values that the thing has. Yeah, and that's it. That's how easy it is to truffle with substrate-based Ethereum, right? So it works out of the box. It comes in the box, but it works out of the box. It has its own provider, but you can, it's configured for you. Everything else is exactly the same. Everything you're used to, your whole test suite, your whole logic, your whole Solidity suite can be just ported over, and it'll work out of the box. You can test it today on a local version of Moonbeam or the Moonbase Alpha testnet. One word of warning is that because this is a proof of stake network, and because there are these differences in how that affects the production of blocks, things like mining difficulty and stuff like that are not going to have any meaning to Moonbeam, right? If your code relies on that sort of stuff, then you're going to have to do some modifications to your code. So if your code makes assumptions, is making assumptions on, if your code is assuming that the chain is a proof of work chain and relies on the values of proof of work to do something, then you're probably going to have a little bit of a harder time adapting your code to this. Otherwise, you should be good to go to just copy and paste things over. It should just work. I don't think I have time for any questions, but please feel free to follow up with me and via email or Twitter or Telegram or whatever. I'm available for any calls, chats, emails, or whatever, and I'm happy to help you out if you get stuck on developing this. And I really do recommend you check out Alberta's talk, who will be introducing a fun new feature of Moonbeam, I think tomorrow or the day after. Thank you all for your attention, and I'll see you around.